Hey. Small correction. Actually, when I just entered the position, they told me that the ML was buzzword somewhere in the 80s, and I'm actually late to the party. But okay, of course, now it has a big revival. So yes, indeed, today I want to talk to you about how do we use ML, how do we leverage ML, and yeah, this is something I'm doing for last couple of years. So yeah, first disclosure: I'm a product manager. I'm not a technical person. I'm not a developer. So please don't judge me too much. Yeah, I work in big companies, so usually I deal with a lot of data, and this is my favorite way of looking at the world, through data. I pick intentionally products where I can do this, and I can actually argue that in some of my products, like recommendation system, you cannot do customer research, you cannot understand your customers. You cannot even understand what your research, what your recommendation machine does. Actually, but you can optimize it. And this is quite fun. So at some point, my career was pretty boring, to be honest. Everything was known in the product manager. I know what I had to do to be a good product manager, and I knew that I was not really doing good because not all of those things I can do good. So yeah, it was still boring because there are frameworks. You need to follow the framework, and then at least nobody will tell you that you're a bad product manager. But then at some point, my career took a turn. I joined a team which was doing ML. And at this turn, things, to be honest, went bananas, because everything which I knew didn't work, or it worked very poorly. And first few months were actually disaster when I did the same things which I did at previous teams, and usually they at least work good enough that managers were happy with this. They didn't work at all. So what I'm going to talk to you about is like what I learned, what is different about doing the ML. So if you really want to, if you feel that you are bad at some topic, you really want to get into it, what do you do? What's the best way to get into a topic?
Search for some
No.
experience.
Okay. The answer I was expecting is you do a conference talk about it, right? Then you really get into it. But then I would say that it's actually wrong. You do a course about it, and this is what I did. Actually, I train product managers to do ML products. I'm totally honest with them. I say that I don't know all the answers, and actually, it's an extremely interesting topic right now. We're still figuring it out. But yeah, this is one of the things I do to get more into this topic. But here for you, I'll bring like the best fruits of what we together with the students and what me personally I have researched about it. So yeah, the task on the board is pretty simple. Don't rush answering to it. But what if I give any of you 2 apples? How many apples have you got? Most developers, they answer correctly that you cannot know. You didn't initialize the variable, right? You don't know how many apples were there to begin with. But this is actually the most common pitfall, or the most common mistake people who start doing ML, they do. Because they see something where they can apply ML, and they start applying it right away, because this is a problem clearly suitable for ML, and ML is a hot topic. Everybody wants to do ML, so let's do it. But the problem is that what I learned, you have always started with a baseline solution. What would you do if you had no ML, if you cannot do ML? What you will start with? And this is probably the most important concept, because in a lot of cases, if you compare even the most advanced ML solutions, you honestly compare them to the baseline. In the best case, there is no difference. In the worst case, there is no difference, but you spend a lot of resources to build and maintain this huge, very fragile machine. I'll talk about it later. And in the worst case, it's just simply worse than you could do with simply like 2 days of backend code. So when I start doing case, I always start with some baseline solution. Let me give you an example, which is distantly based on a true story. So there was a data scientist on my team who said, hey, I studied the data. We have a lot of data about customers coming to our store, platform, whatever, some e-commerce site. And I can predict in which category the customer will most likely make a purchase. And the accuracy of this predictor is like mind-blowing, 72%. And of course, he was super proud of himself, and all the ML managers and other managers said, "Oh yes, this is great. We should definitely use this predictor." So what we did, of course, we implemented some kind of recommender, gave it the best real estate on the front page, and said, "Okay, we know where the customer will go, so let's put it." So what do you think was the result of this experiment?
The conversion went down.
They didn't pay.
Okay, no, the conversion didn't go down. So people did actively use this thing, and they use this navigation advice, and they use it to get to what they're going to purchase. But the impact on the conversion was absolutely zero. So it didn't move like an inch. Though we had implemented this, of course, fueled it with data, spent a lot of resources, but the actual impact on the business was absolutely nothing. And okay, I'm not going to tell you who was also involved in the story, but I can honestly say that I was part of it. And which lesson did I learn from this? That not all. So you, as a product manager, it's your obligation to start thinking about solving this particular problem, which we totally can solve with ML, does it lead to business growth? And I think what I missed in this case, right, that usually they teach us as a product manager, like the basic, right, to think about two things: the problems which our customers have and the solutions. And by all this happy crowd who said, "Oh, we have the prediction," I was immediately pushed to this. We have a good solution. Let's use it. But nobody asked if the customers actually have a problem getting to where they want to go. And in this particular case, it was totally not a problem. There was, the catalog otherwise worked pretty well. So yes, we cut the path short a little bit, but it had no impact on our customers. When you start applying ML, think about if you're applying it to something which really will move your business forward, not just become a useless implementation on your side. But actually, I learned that having a very reliable or having some alternative to the ML you are going to do is also valuable from other very unexpected perspective, and this is more technical one. I think that having this alternative is very important for you to be able to do fast innovations. So I had this problem. I was trying to build a pretty important recommender system, and in this case, it was really helpful for the customers. So without it, we saw the conversion much lower than with it. But there was one problem. It was sitting in a very crucial path of a customer. Basically, it was sitting in the basic search. And so if we didn't respond in time with the search results, of course, it was a disaster. People got like empty search or broken page or something like that. And nobody wants to break the most critical path. But still, we had an algorithm which could recommend things to people much better than any other alternative. And the problem was it was very, very fragile. So I was actually, you can call it a stakeholder management problem. So there were people who were responsible for the main customer flow, and they were saying, "No, you're not going to work here because you are breaking it far too often. Every time you do a release, there is a high chance that we need to do a rollback. We have downtime. We are not maintaining our SLOs. So no, stop working here." Or they were blocking my release, and they say, "Okay, yeah, we're going to test it thoroughly." So they made my release being like 3 weeks instead of 2 days, and it was really pain. I cannot innovate at the velocity of like 1 release per 3 weeks. So how did we solve it? We realized that we need something which will be super reliable and which will actually switch in case there are any problem with this new fancy recommendation machine which we were building. So in case they called our service and it couldn't return reasonable results, it was going to some other path, and this thing was stupid, very, very stupid. It was very reliable, and it's set in the main service, right? Not in our service. So anything bad happens to our service, then we have a fallback which we build and maintain inside their service. So now actually rolling out this service was very safe, because if something bad happens on this call, then it just uses the fallback. And yeah, we had some advantage in terms of conversion. So these things work like, I don't know, significant amount of percent, at least in money for us, better than this one. But this is good enough. So if these things works for, I don't know, 15 minutes, this is not a big deal. And this actually unlocked us a lot, because now we could release this service 2 times a day. Nobody objected. And actually, to go forward with it, we also handed to our upstream team this panic button, because they were always nervous about our innovation. So we gave them a feature and said, OK, if you have any worries that it's about us, just press it, and it will cut off our service out of the system. And we have measured the fallback cost. So we know what it has to cost to be on the fallback for 1 minute, 2 minutes, 1 hour, and so on. And so you can just calculate it. So you can totally afford for 1 hour per week to sit on the fallback. So if you have any worries, just press the button. And yeah, this made our relationship so much better and so much more effective. So this is another reason why when I'm starting doing ML, I'm always thinking about, OK, what will be my fallback solution? Because having a fallback solution actually allows me to move much faster and not think about all the risks which I am creating. Because most of the ML solutions are still pretty much unreliable. And why is that? Here, I need to explain one thing. So this actually comes from Andrew and Jeans, not me, who is so clever. This is very, very nice formula which explains to you how things work when you're doing ML. Yeah, it's data plus code. The problem is that people always were saying, like, you have to create data, then you create code, which actually creates the model, right? And everybody is saying that nobody is thinking about the data. And I thought, oh, OK, now they told me, and I know that I should not be only thinking about how do I train my models, but also about the data, right? Now this thought sits in my head. But it turns out that I think it's some kind of a bias, like some other biases which we talk about a lot, which even if you know that it's there, it's very hard to overcome. So most of the development teams, just instinctively, just because there are a lot of developers, they start spending a lot of time here and not a lot of time here. And this results into this thing being much, much too good for the task, and this thing being sometimes really crap. And the whole thing, of course, works ineffectively as a result. And I started portioning the work in my team. So basically, I have sometimes they say you need to dedicate 20% to the technical debt or something like that. Yeah, now I'm trying to maintain something like 50-50. So 50% of our efforts should go to improving just the data. And in a lot of cases, not touching the code, not doing a single commit, we can improve the final result by just having some improvements here. And I would say that, at least for my cases, those things, based on experience, they weight pretty much the same. So you should be spending half time there, here, half time there. Maybe after some experience, I will have more precise weighting for them. The problem, there are a lot of things which can happen with the data, and I will talk a little bit about them because everybody knows what can be wrong about the code, and we have a lot of talks and books about how good code works and how does it look like. But I think we are not that mature yet as an industry with how does the good data and good process for the data looks like. So I'll stop here for a bit. So, OK, first pitfall, yeah, I hope we talk about it a lot. You need to have enough data. And yeah, some people start when they don't have enough data. When actually they have, I don't know, some few thousands of examples, while they need hundreds of thousands. Or maybe they pick an ML architecture which requires much more data than they actually have, because they have enough data to work with regressions, but they start working with deep learning. Yeah, of course, you can benchmark yourself against some papers in the industry which say, like, oh, how much of examples do you typically need for the architecture which you are planning to use? The representative data, for product managers, it's actually even more hard than having enough data, because in a lot of cases, we don't do ML just to do ML or do predictions and be super happy about how precise they are. Usually we do predictions to change the site behavior, which automatically makes the data which we train on non-representative, right? And it's a little bit about the talent and your intuition to understand how exactly is this and which features you should avoid using, because when you change how your site behaves, then they automatically behave, they'll become non-representative. For example, you think that really important signal is when your customer clicks on the gallery. And you decide, oh, let's build some mechanics which is based on this, if customer click on the gallery or not. But then as a part of changing the site, you make the gallery much bigger. So now much more people click on the gallery just because it's bigger and more prominent in the site. And now this feature has totally different meaning from what you trained on. And yeah, this happens a lot of time because unfortunately we pretty much always train on the data, the same data, which we are then changing with our actions. Quality and freshness, I think, are more or less self-speaking, especially, well, COVID, I think, taught everybody about how important is the fresh data, because I'll talk about this in a little while, but I think it was a big anomaly, after which, for a lot of models, all the previous data became absolute. And then everybody started training on the small portions which they have got, and everybody saw on practice how it is important to use the fresh data, especially when something big happens in the market. Another topic which I want to talk about is the problem between online and offline. For me, it's like, I don't know what is the best example of two worlds which never meet. So I chose Barbie and Oppenheimer. The way it works, at least in my team, data scientists, they live in Barbie world, right? Everything is possible. They can grab any information, enrich the data, process it, I don't know, clean it up, and then do some magic. And also, they don't actually measure themselves against the real world because they don't start changing the product immediately, right? They choose some metric, like, I don't know, NDCG for recommendations, or maybe accuracy of the accuracy for some predictions, and then they measure and say, okay, we are actually doing good against these Barbie metrics. But when they go into the real world, everything is different. You don't have the data you need in the times which you need. You cannot really quickly remove bots or remove some other noise from it. So actually, this world is not really attractive. And there is a big problem of going from one world to the other with what you have done in that world. Another big problem, which I hope that the industry will solve. Actually, if you know a good solution, please tell me. I don't know a good solution, but all the things those guys do in the Barbie world usually is written in Python, right? They process the data, they toss and slice it in Python, and then they say, okay, I did it, here are my features. But then if you need those same features in real time, if your model is not working offline, if it's working in real time, then I come to a backend developer and say, okay, you need to do the same magic. You have to process the data the same way and produce the same feature as they did in Python. So what is the probability that two people working on two different paradigms and in two different programming languages will do the data processing the same way from the first time? I have the statistics, and it's 2 digits. Like when we just start, when we reproduce the features from Python to Java, usually we have 2 digits of features which just don't work from the start, because it is not possible. The textbook example is like you ask people to calculate the time difference in days, and then you notice that in training data you have zeros, in production you don't have zeros, because rounding is different, and so somebody thinks that if it's the same day, it's 1. The other person thinks it's the same day, it's 0, right? And only by monitoring features, you can actually learn that this thing happened. And this leads me to another big problem. How do we learn that such things happen? Because we're used to having really good monitoring, but what this monitoring is based on, right? We usually react to errors. Yeah, if something fails, if a piece of code fails, it throws a warning or an error, and then we can know, okay, something is wrong there, and there is a pager duty, and somebody rushes to fix it. But the problem with the model is if you supply wrong data to it, it doesn't fail. This is why we love models. It can work with any garbage and it will still do something. But this is the problem. So with the example which I just talked about, with not having zeros in training and having zeros in production, only by looking at the data, the model was totally producing the result. It was just wrong. And there was no obvious way to know that it is wrong. So when you are building a model, you need to understand that it is super fragile, and actually you need to do a lot of, you need to invest a lot of efforts in monitoring. Because it doesn't have very obvious ways to fail, but it will fail over the time. One big problem which I see with model failing very frequently about the data is this imbalance in the organizations between data producers and data consumers. I don't know if you use the same language, but most probably in your organization there are also teams which, for example, they sit on the front end, they create the interface, and they instrument the different events with data, right? They're data producers. They create the data. So then we sit somewhere in deep in the basement and deep backend, and we train the ML models using this data. So we are the data consumers. But there is no motivation intrinsically for the producer to actually keep the data right. So if they redesign the interface a little bit, or they change how they record some things, usually they don't even notify anybody. So new data starts going down the pipeline. And if you don't have good communications, if you're not proactively monitoring it, you start getting new data here, and your ML model keeps working. It just gets another data. For example, if they decide to record the time difference not in days, in weeks, and they start doing it, you still get the same valid integer. It just means totally different thing. And this sounds, I know this maybe sounds a little bit silly, but I have seen in a pretty big organization, we have a lot of resources to monitor such things. These things happen very often because we don't have really good frameworks to monitor the data consistency over the whole pipeline. So, this is especially true for models which use a lot of data. With the best models, they use a lot of data from very different sources. For example, they use something from mobile, from the web. They even use something from the call center. So if somebody changes how the calls and the call center are recorded, this will go into the pipeline. And good luck monitoring all those streams and making sure that you are still getting the same results. And of course, mobile app and the web are developed by totally different teams, right? So to make them record some data consistently in the same way, it is a big challenge. It is even a big challenge to monitor it here and detect all those anomalies, given that some data, let's say you take an example and you check if it's correct, and it comes from web, it's correct. But then you understand that actually the wrong data is only coming from mobile, not only from mobile, but from mobile when people are using maps. Then you start getting wrong data. But still, some of the predictions for your model and some of the training data will be incorrect, and it will significantly reduce the final effectiveness of the whole thing. Even if we rule this out and we have really good contact with everybody and all the data producers are super conscious about giving you the right data or notifying you about if they change something, we have this problem of natural drift, which is completely, totally our obligation to monitor as an ML team. Because, markets change, so also the parameters change. And now I'm talking about maybe slow-moving changes, like, okay, something introduced, more people start using mobile, more people are traveling to some countries, and so on and so on. And over time, the effectiveness of your model will degrade, and you have to monitor all those things, because if you see that, okay, you trained and most of your data contains some distribution of values, and now it's totally different, then most probably the predictions you are giving are not really correct. And it is very, very hard to catch. But even harder it becomes when something really big, we call it a concept drift, when a big shift happens in the market. And COVID is a perfect example of that. So when the COVID came, right, at some points, as the lockdowns were rolling from country to country, we knew that all the models will now become obsolete. We knew that now the behavior will change dramatically, and we don't know how. So to maintain the predictions or recommendations which are powered with ML working, sometimes we had to intervene just manually and say, okay, we know that people will want to be more flexible, that people will cancel more, and that people are more afraid, so let's do something. But yeah, there is no way to know what will happen. You just know that this thing which you have will stop working. And if you don't have this very hard-coded alternative, then you could be in a big trouble because the effectiveness will drop. And because there are big shifts in the market, you won't even know how big of the problem. Maybe the conversion dropped for the whole market. Or maybe it dropped because right now your search, your recommendations, your email marketing stop working properly. Yeah, you don't have really good benchmarks at this moment. But at least it's very important to monitor what happens, like I showed on the previous slide. This one. So to know what did change. For example, you see, okay, most people now want to be flexible. They really want to be sure that they can cancel. Okay, let's maybe introduce this. Let's start weighting the latest examples much more than we weight the long history, and start introducing more flexibility proactively. Maybe even manual intervention makes sense at this point. But at least let's detect and let's be honest with ourselves that our ML cannot work in the situation which it have never seen in the training, because it cannot do magic, it can only do extrapolation. Even if we don't take the big events on the market, then usually models degrade over time. In my company, there are a lot of things like okay, somebody introduces something, then it lives for a year and a half, but then somebody comes, they have fresh new ideas, and then they want to remove some part of the page or something because they need space for something, some new feature. So they start blacking out, removing pieces of code, and then they see, oh, actually removing this doesn't move. When they introduce this part, it gave us a boost in conversion. Now when we remove it, nothing happens. Why is that? And this happened a lot with ML models specifically. And I think one of the problems is that, yeah, if you don't do anything, if you proactively don't maintain it, then it degrades usually because of the feature drifts, because of the concept drifts, just because maybe you should think about the ML code or ML piece which you deploy as a baby. Yeah, usually code you can deploy to production, and then you need to monitor that it doesn't have too much errors. And yeah, basically you are good. Well, there is technical debt, but it's not very big one. With ML, it's times more. So if you don't do anything, it will degrade, and it will degrade pretty quickly. And I just told you there are a lot of ways it will fail, which are not very obvious, and you need to invest a lot of time to monitor and keep watching that it's still getting the data still means the same, there is no drifts and so on. So yeah, just think about it as a baby. If you start doing it, then you have to keep paying attention to it for quite some time, actually for all the lifetime. Unfortunately, they never graduate, they never leave parents' home. So this actually created for me this barrier. Now, if people tell me, okay, let's do this new model, and I even see that there is an increase for business, I'm really asking myself, is it worth the overhead which we will have, because it's a big one? And I'm especially against, like, somebody says, oh, I created a new model which is specifically for this segment. So now let's have 2 models for this segment and for all the rest. I understand how much does it cost to maintain a model. I'm saying no. Unless it gives like a lot of improvement to the target metrics, we're not going to do that. It's much more profitable in the long term to keep just one model and not spend too much on the maintenance. Another problem which we have when working with ML is that what we measure offline when we're preparing the model actually doesn't equal what we see in real life. So when you start doing it, you need to understand that, okay, I can measure precision of the predictions offline, but what I'm going to measure in the real world, something like conversion. they might be correlated, they might not. So what I'm showing is ideal situation, right? It's almost perfect correlation, which was actually observed for some of the models. But it's not always the case. Not always you can create an offline metric for a model, which will be correlated strongly with what happens online. Not always it does play some role in the customer behavior. So don't expect it always to be like that. So first you need to actually measure this. Every time you deploy a new model, you have to compare, okay, what did I see offline? What do I observe online? And if you don't have the correlation, then it's a really red flag. Another finding which I want to share is that maybe we're doing experimentation. You can really tailor the experimentation to ML, because usually we experiment like I showed you before, A/B testing, right? We show one experience to one customer, another experience to other customer, and then we compare who converts better. But actually, yeah. To explain on an example, this is a little bit like this. So we put some customers in the bar where they serve Coca-Cola, some customers to the bar where they serve Pepsi, and we compare who drinks more. But probably you already feel why we lose the sensitivity here. Because some people, even they don't like Pepsi, but they still drink it if there is no alternative. So actually what hurts me a lot while tuning ML models are people who are really loyal and love our product, because they will book anyway. They don't give me a signal. So there is actually a very tiny group of people who will change their decision because I screwed up the recommendations. And this is a big problem, because when you tune your models, this is the most important signal which you get. So what I learned, that in some cases, it is possible to hack this problem. And it gives you a big boost in the velocity. Because you can, when recommendations, you very frequently serve multiple items, right? For example, if you recommend products, you can show, I don't know, 5, 7, 6 products in a row. And in this case, you can actually use 2 algorithms, but then do something which we call interleaving. It's like that, right? You just toss a coin who comes first, and then two algorithms recommend 2 different lists. But then you interleave them like that, and then you just count which one gets more clicks and more purchases. And this is so much faster. So this is results published by I think by Netflix. They use this technique to improve the galleries of films you can see. So they use 2 algorithms and interleave them. And so this one is logarithmic, don't confuse it. So they are saying that for the interleaving, they have 100 times, they need 100 times less data than for A/B testing. This sounds crazy, but I just explained you how it works, and it actually works. In the case, if you can show multiple recommendations, this is really a life changer. And this is data coming from my company. We published a paper about this. So in our case, it was the same. What we did, we ran experiments for a very long time, and then we took small pieces of data and they compared, like simulated the situation where we would run very short experiments. And in this case, we confirmed that actually to get the qualitative outcome, like which algorithm is better, you can use this technique, and it will require 100 times less traffic than an A/B test would. But the problem is this thing, because you will know which one is better, right? But this doesn't mean that the conversion will increase. So sometimes you get a better algorithm, but it doesn't mean anything for the conversion. And this can also happen. It just means that you are playing with something which doesn't make that much difference for the customer journey. And I want to conclude with asking myself, I just told you about a lot of things which are really super annoying. And yeah, they annoy me, and they annoy me every day. It is really hard to do ML. It's uncharted territory. So now that I think of it, there should be frameworks which really bridge the online and offline world. There should be more frameworks which allow you to do feature monitoring. There are some, they start to emerge, but still there are no really good solution. You have to figure out a lot of things by yourself. But I still think that doing ML is worth it, because in a lot of places, unlike some other topics, which may be even discussed on this conference, I don't think this is a real hype. I think some of the products, they won't work in 5 years. They won't work without ML at all. Yeah, you know, examples like ChatGPT or maybe self-driving cars, which are, maybe decent examples. But if you think about the online advertising, you cannot start your own online advertising engine without using ML. It's just not possible. So more and more things will only be driven by ML. So I still think it's worth getting into this, getting your hands dirty, and maybe building some ML solutions. And here is a link to my LinkedIn, in case you're interested. Yeah, if you want to send maybe your product managers to learn more about ML from other practicing product managers, yeah, you're welcome.
Questions?
So I will start. But basically, my question is about how to start. So probably we'll own some products, and how to define what is basically worth applying ML on it. So how to define that you really can do something with it.
Unfortunately, yeah, I don't have a really good answer. I would say something like experience maybe, but even this doesn't really matter. So what I'm using is I'm looking at the industry really closely, because right now a lot of people are trying to use ML in different things. They start powering their chats with it and so on and so on. And I'm really focusing like, okay, who did get real success? I mean, real success, not we launched. We launched, there was a lot of noise. But who said that, okay, this is now driving our business. It brought us some business results. I'm really paying attention. And also, you can really ride on the vanity of the data scientists, because when they do something really cool, they publish a paper. And paper has much more details than the press release. So yeah, we usually read papers especially from our competitors, to see where did they actually succeed and what data do they share about it. Okay, then thanks for having me.